the silent law that keeps stars from exploding. Every star is a battle frozen in balance. A single failure would tear it apart instantly, yet most stars survive for billions of years. To understand why stars do not explode, we must look inside them. Stars are not peaceful objects. They are engines of extreme violence. Temperatures reach millions of degrees. Pressures crush atoms together. Energy is constantly trying to escape. At their core, stars burn fuel relentlessly. Nuclear fusion releases enormous energy. That energy pushes outward with tremendous force. Left unchecked, a star would rip itself apart. Explosion is a natural outcome. For a long time, this puzzled scientists. Why did stars not detonate like bombs? Why did they shine steadily instead? What invisible hand held them together? The answer came from a quiet, universal rule. Gravity pulls inward relentlessly. Every particle attracts every other particle. In stars, gravity is overwhelming. It crushes matter toward the center. It fights the outward push of fusion constantly. This balance is not gentle. It is precise. Too much fusion, and the star swells or explodes. Too much gravity, and the star collapses. Stars survive only by walking a narrow line. Perfect imbalance means destruction. This hidden equilibrium shapes the entire universe. It decides how long stars live, how bright they shine, how heavy elements are created. Everything you see in the night sky depends on it. Even now, stars are not static. They adjust continuously. Fusion rates rise and fall. Gravity responds instantly. Each star constantly corrects itself. A cosmic negotiation without pause. This silent law has no warning signs, no alarms, no countdown. When balance fails, collapse or explosion follows suddenly. Supernovae mark moments when equilibrium breaks. But most of the time, the law holds. Because of it, galaxies glow, planets form, life becomes possible. This unseen balance keeps the universe calm, but it is more fragile than it appears. And understanding it reveals how close everything is to chaos. This balance is called hydrostatic equilibrium. It sounds gentle. It is anything but. Inside a star, forces clash without rest. Fusion in the core releases photons and particles. They collide with surrounding matter. Each collision transfers momentum outward. This creates pressure. Pressure pushes against gravity's pull. The star inflates slightly in response. Gravity immediately answers. As the star expands, gravity weakens slightly. Fusion slows. Pressure drops. The star contracts again. This feedback keeps stars stable for millions of years. Balance emerges from constant correction. However, this equilibrium depends on fuel. Stars burn hydrogen first. When hydrogen runs low, fusion changes. Different reactions begin. The balance shifts. Stars swell into giants or collapse inward. Evolution begins when fuel changes. Small stars burn slowly. Their gravity is gentle. Fusion proceeds calmly. They can shine for trillions of years. Large stars burn fast. Their gravity is fierce. They race toward instability. As fusion progresses, heavier elements form. Each step releases less energy. Gravity gains advantage. Pressure weakens. The core contracts. Temperature rises. A new fusion stage ignites briefly. Stars climb a ladder of elements. Eventually, the ladder ends. Iron forms. Fusion with iron consumes energy. The core loses its support. Pressure collapses. Gravity wins in a heartbeat. What happens next depends on mass. Some stars shed their outer layers gently. They leave behind white dwarfs. Others collapse violently. Their cores rebound. Shock waves tear the star apart. These explosions scatter heavy elements. Carbon, oxygen, iron, gold, everything needed for planets and life. The same balance that prevents explosion also prepares the conditions for it. This reveals the paradox. Stability creates the ingredients of instability. The law that keeps stars intact also sets the stage for their destruction. Balance is not permanent. It is borrowed time. As stars approach this tipping point, tension rises quietly. Nothing dramatic appears from the outside. Light still shines. Gravity still holds, but the balance is thinning. Inside the core, reactions grow desperate. Fusion demands higher temperatures. Gravity squeezes harder. Pressure spikes, then weakens again. Each cycle shortens. Stability becomes increasingly fragile. For massive stars, the end comes abruptly. When the core collapses, it does so faster than light can escape. Atoms are crushed together. Electrons merge with protons. Neutrinos flood outward. The core becomes incompressible. In that instant, gravity overreaches. The collapsing core rebounds violently. A shock wave races outward. The star tears itself apart. A supernova ignites brighter than entire galaxies. This explosion is not random. It is balance failing catastrophically. The same forces that held the star together now rip it open. Equilibrium flips into destruction. Smaller stars end differently. They shed layers slowly. Gravity relaxes its grip. The core cools into a dense remnant. A white dwarf glows faintly. Stability fades without violence. Either way, the law remains undefeated. Hydrostatic balance governs every phase. It allows stars to live. It decides how they die. Nothing escapes its authority. This reveals a deeper truth. The universe does not favor permanence. It favors process. Stars are temporary negotiations between forces. Their lives are chapters, not endpoints. Even now, every star you see is mid-argument between gravity and pressure, a momentary compromise, a glowing delay against collapse. The sky is full of borrowed balance. Understanding this reframes the night sky. Those distant lights are not peaceful. They are restrained, held together by a rule that never rests, a rule that will eventually let go. The climax of this story is not the explosion. It is the balance that delays it. For billions of years, gravity and pressure hold each other in check. A quiet standoff shaping the universe. Stars are not stable objects. They are control failures. Gravity constantly tries to collapse them. Fusion constantly tries to tear them apart. Existence happens between those extremes. This balance explains why the universe looks the way it does, why stars shine instead of detonating, why galaxies glow instead of vanishing, why heavy elements exist at all. Stability creates time. Every atom in your body passed through this process, forged inside stars, released when balance finally broke. You are made from negotiations that ended long ago, from stars that lost their grip. This makes the law deeply personal. Without it, there will be no carbon, no oxygen, no planets, no life. The same rule that prevents destruction also makes creation possible. Yet balance is never permanent. Every star will fail eventually. Fuel runs out. Gravity waits patiently. The law does not promise survival. It promises fairness. When support ends, collapse follows. Understanding this changes how we see stability. What looks permanent is temporary. What feels secure is actively maintained. The universe survives by constant correction, not by stillness. Stars teach a quiet lesson. Lasting things are not unchanging. They are carefully balanced. They endure by adapting continuously. When adaptation ends, transformation begins. This is not just astrophysics. It is a pattern everywhere. In systems, in structures, in lives. Balance keeps things alive, but it is always borrowed. Sometimes the smallest shift in perspective becomes the beginning of a new future. The